Plastic. It's everywhere. From the packaging of our daily groceries to the toys our children play with. Plastic has become an inseparable part of our lives. From the deepest ocean trenches to the Arctic ice, our planet is choking on it. Marine life, like this sea turtle, suffers immensely, often becoming entangled or ingesting plastic debris. We produce mountains of plastic waste every year. In fact, over 300 million tons of plastic are produced annually, and a significant portion of it is single-use. Most of it ends up in landfills, where it takes centuries to decompose. These plastic bags, for instance, can take up to 1,000 years to break down, releasing harmful chemicals into the soil and groundwater. The rest pollutes our oceans, harms wildlife, and even enters our food chain. Birds mistake plastic for food, and fish swim through waters filled with microplastics, which eventually make their way onto our dinner plates. The scale of the problem is staggering. It demands urgent action. We are at a critical juncture where the choices we make today will determine the health of our planet for future generations. We can't keep burying our heads in the sand. Ignoring the problem won't make it go away. In fact, it will only get worse. The consequences are too dire. Marine animals are dying, ecosystems are being destroyed, and human health is at risk. We need innovative solutions to tackle this global crisis. Engineers and scientists around the world are working tirelessly to find sustainable alternatives and effective waste management strategies. This is where the idea of turning plastic waste into fuel comes in. It's a compelling proposition. By converting plastic into fuel, we can reduce the amount of waste in landfills and provide a new source of energy. It offers a way to address both plastic pollution and our growing energy needs. This dual benefit makes it an attractive solution for many countries struggling with waste management. Could this be the answer we've been searching for? With continued research and investment, turning plastic waste into fuel could become a viable and widespread practice, helping to heal our planet. Imagine a world where plastic waste is no longer a problem. Imagine it as a valuable resource instead. This is the promise of plastic-to-fuel technology. It offers a way to transform our trash into treasure. This process involves breaking down plastic waste and converting it into usable fuel. This technology is gaining traction around the world. It offers a compelling solution to two pressing problems. First, it helps to address the growing issue of plastic pollution. Second, it provides an alternative source of energy. This could reduce our reliance on fossil fuels. The process of converting plastic waste into fuel might sound like science fiction, but it's surprisingly straightforward. This innovative approach is gaining traction as a viable solution to the growing plastic waste problem that plagues our planet. By transforming discarded plastics into valuable fuel, we can address both waste management and energy production simultaneously. There are several different methods, but they all share a similar principle. Each method aims to break down the complex plastic polymers into simpler, more useful forms. This not only helps in reducing the volume of waste, but also provides an alternative source of energy. At its core, it involves breaking down the long chains of molecules that make up plastic into smaller, more usable hydrocarbons. These hydrocarbons can then be refined and processed into various types of fuel, such as diesel, gasoline, or even jet fuel. One common method is called pyrolysis. This technique has been extensively researched and developed over the years, making it one of the most efficient ways to convert plastic waste into fuel. In this process, plastic waste is heated in the absence of oxygen. The absence of oxygen is crucial because it prevents the plastic from burning and instead allows it to decompose into simpler substances. This breaks down the plastic into simpler components, including fuel-like gases and liquids. These byproducts can then be further refined to produce high-quality fuels that can be used in various applications. Another method is called gasification. This process is slightly different but equally effective in converting plastic waste into useful fuels. This process involves reacting the plastic with controlled amounts of oxygen and steam. The controlled environment ensures that the plastic is converted into a synthesis gas, or syngas, which is a mixture of hydrogen, carbon monoxide, and other gases. This creates a gas that can be converted into fuels, like methanol or ethanol. These fuels are cleaner alternatives to traditional fossil fuels and can be used in various industrial and transportation applications. These processes can handle a wide variety of plastic waste. From everyday household items to industrial plastic waste, these methods are versatile and adaptable. This includes plastics that are difficult to recycle using traditional methods. For instance, multi-layered plastics and certain types of packaging materials that are usually non-recyclable can be processed using these advanced techniques. This makes plastic-to-fuel technology a potentially versatile solution to our plastic problem. By converting waste into fuel, we not only reduce the environmental impact of plastic waste, but also create a sustainable source of energy for the future. This dual benefit makes it an exciting area of research and development with the potential to make a significant impact on both waste management and energy production. The environmental benefits of turning plastic waste into fuel are significant. First and foremost, it helps to reduce the amount of plastic that ends up in landfills and the environment. By diverting plastic waste from landfills, we can reduce the release of harmful greenhouse gases. Landfills are a major source of methane, a potent greenhouse gas. Moreover, by creating a new use for plastic waste, we can reduce the need to produce virgin plastics. This in turn can help to conserve natural resources and reduce the environmental footprint of plastic production. Section 5, Fueling the Future, Energy Security and Economic Advantages. In this section, we delve into how transforming plastic waste into fuel not only benefits the environment, but also offers significant energy and economic advantages. Beyond the environmental benefits, turning plastic waste into fuel also offers potential energy and economic advantages. This innovative process helps to address the growing problem of plastic waste, while simultaneously providing a valuable resource. It provides an alternative source of energy that can help to reduce our dependence on fossil fuels. By converting plastic waste into fuel, we can diversify our energy sources, making our energy supply more resilient and sustainable. This is particularly important in a world facing increasing energy demands and concerns about energy security. As urban populations grow and industrial activities expand, the demand for energy continues to rise, making it crucial to find reliable and sustainable energy solutions. From an economic standpoint, plastic-to-fuel technology can create new jobs and stimulate economic growth. The development and expansion of this technology can lead to the establishment of new industries and markets. Building and operating these facilities creates jobs in construction, operation and maintenance. These jobs not only provide employment opportunities, but also contribute to the local economy by supporting related industries and services. Additionally, it can generate revenue from the sale of the fuel produced. This revenue can be reinvested into further research and development, enhancing the efficiency and effectiveness of the technology. This can help to offset the costs of waste management and create a more circular economy. By integrating plastic-to-fuel technology into our waste management systems, we can reduce landfill use, lower greenhouse gas emissions, and promote a more sustainable and economically viable future. Section 6. Not a perfect solution. The drawbacks. While the potential benefits of turning plastic waste into fuel are significant, it's important to acknowledge that it is not a silver bullet solution. There are potential drawbacks and challenges that need to be carefully considered. One of the main concerns is the potential for air pollution. The conversion process can release harmful pollutants into the atmosphere if not properly controlled. These emissions can contribute to smog, respiratory problems, and other health issues. Additionally, the type and amount of emissions can vary depending on the specific conversion technology used and the composition of the plastic waste being processed. Section 7, Emission Concerns, a closer look. While some argue that the emissions from plastic-to-fuel plants are comparable to or even lower than those from traditional fossil fuel processing, others express concerns about the release of specific pollutants. For example, the process can release heavy metals, dioxins and furans, which are highly toxic and can have long-term health impacts. Strict regulations and advanced emission control technologies are crucial to mitigate these risks. Continuous monitoring and improvement of the technology are necessary to ensure that it truly offers a cleaner alternative to traditional waste management and fuel production. Section 8. the economics of transformation, costs, and scalability. Another challenge is the economics of plastic-to-fuel technology. Building and operating these facilities can be expensive. The technology is still relatively new, and the costs need to come down to make it more commercially viable. Furthermore, scaling up the technology to handle the vast quantities of plastic waste generated globally remains a significant hurdle. It requires significant investment in infrastructure, technology development, and public awareness campaigns to promote recycling and responsible waste management. Section 9. A bridge to a sustainable future. Despite these challenges, turning plastic waste into fuel holds promise as a potential bridge to a more sustainable future. It's not a perfect solution, but it offers a way to address two pressing global issues simultaneously: plastic pollution and our reliance on fossil fuels. The key lies in pursuing this technology responsibly. This means investing in research and development to improve the efficiency and reduce the environmental impact of the conversion process. It also means implementing strict regulations to minimize pollution and ensure the safe operation of these facilities. Section 10. A call to action beyond plastic to fuel. Ultimately, turning plastic waste into fuel should be seen as part of a broader strategy to address our plastic problem. It's not enough to simply find new ways to deal with the waste we generate, where we also need to reduce our reliance on plastic in the first place. This requires a fundamental shift in our consumption patterns, embracing a more circular economy where products are designed for reuse and recycling. It also requires investment in innovative materials and packaging solutions that reduce our dependence on plastic. Let's make conscious choices today to create a cleaner, healthier planet for generations to come.